Hi, Tom. I have another computer programming challenge for you. I'd like you to demonstrate Buffon's needle problem. In your program, show me a field of randomly tossed needles and a graph that charts the approximations of pi's value. Are you up for that? I'll check back in with you later to tell you what I thought of it.
Hey, Louie. Good morning.
Good morning, hello. Ready to start the day with a big smile. What fun are we up to today?
Well, I have a little challenge from TomBot. Do you know who TomBot is?
I'm not familiar with TomBot, but I'm curious to learn more. What's the challenge he has for us?
TomBot has asked me to write a Java program that demonstrates Buffon's needle. Do you know what Buffon's needle is?
Could you please clarify what you mean by TomBot or provide more context on the performance riddle so I can assist better?
Yes, I am interested in the mathematical problem of Buffon's needle.
Buffon's needle is indeed a fascinating mathematical problem. It involves dropping a needle of a certain length onto a plane with parallel lines drawn on it and calculating the probability that the needle will cross one of the lines. This problem combines aspects of geometry with probability theory and demonstrates an interesting way to approximate the value of pi. If you need help with the mathematical details or a Java program for Buffon's needle, feel free to ask.
Thank you for that, but I'm going to write the program myself and I'll show it to you and TomBot when it's finished. Thank you for now, and you can go back to sleep. So, as Louis explained, Buffon's needle is a problem. And what I've attempted to do in this Java program is to give a graphical demonstration of how the formula that Buffon used, which is approximation of pi, would be equal to 2 times the length of each needle, and all the needles are 10 pixels in length. So 20 divided by the width of each slat, and all the slats are equal in width and they are all 20. So it'd be 20 times, and then p is the percentage of needles that fell on cracks. In other words, the lines here that mark the separation of the strips of wood. And that percentage is found by taking the number of, well, let me get it running here, taking the number of needles that actually land on lines, taking that number and dividing it by the total number of needles that were dropped. And I have it set to drop 810, and so the percentage would be 261 divided by 810 times the width of the width of the slats, which is in this case 20. So that's how it operates, and you'll notice that as the program runs, the approximation gets better and better. And every time it runs, we're going to have a different number of crossed lines because these are randomly placed, which means there's a stochastic element in the program. So I thank you for watching.
Well, that was curious. Thanks for accepting my challenge, Tom. My only complaint is that your video ran too long. I'd suggest leaving Louie out of it next time. I am your ever-friendly TomBot saying, bye for now and have a safe and happy day.